In this video we shall talk about dependency theory. Of course, dependency theory itself is much wider, deeper and complex than any video may cover, so please refer to these books or any other books you like for more details. Soon we shall discuss normal forms, and those normal forms are based on some dependencies. So for now, we absolutely have to study those dependencies in order to understand normal forms themselves. And there is one extremely important fact. That is, each and every dependency existence depends on subject matter only and only. It is, if subject matter rules change, any dependency may either appear or disappear in any relation without any changes being made to the relation itself. So, the subject matter is the only source of existence or non-existence for any dependency. Please remember this fact, it's absolutely necessary to understand. Zero normal form and first normal form are not related to any dependency. We shall see it in some next videos. So for now we are going to second normal form right now. The second normal form depends on functional dependency. This is a situation when two or more tuples having the same values for some X set of fields, and so they have to have the same values in Y set of fields. This is how it may look like from the mathematics elementary course or something like that. We have x-axis, y-axis, and we see if, for instance, there is some x5 and x6 and they are equal, and we may see y5 and y6, those are equal too. But please remember that all this works only this way. If, for instance, we make such a line, we see 1, 2, 3 values, all y values are the same here, but x values are not the same. So it doesn't work backward, it only works forward. Here are some examples. When a functional dependency exists, for instance, with one passport ID we have one full name. For one employee ID we have one value for work experience. For one set of student and subject we have one mark. But please be attentive. Here is the situation when functional dependency does not exist. For instance, for one passport we may have several names in case a person changes his name. For one employee ID, we may have several work experience, for instance, in different areas of expertise. For one combination of student and subject, we may have several marks in case of several attempts to pass an exam. So once again, each and every dependency existence depends on subject matter only. With these subject matter rules, dependency exists. With these subject matter rules, the dependency does not exist. There are several kinds of functional dependency, like full and partial. With full functional dependency, imagine we have a set of fields like ABC here, and we absolutely have to have all those values in order to determine Y value. With partial functional dependency, for instance, we have the same ABC, but we may omit some value and we still be able to detect Y value. This is how it looks like with data. We have some information about exam results. We see student's ID here, subject's ID here, and the exam mark. We have full functional dependency here, because in order to know the mark, we have to know student ID and subject ID. Imagine a situation that we do not know subject ID, we only have student ID. We have several records for it. Imagine we have, for instance, 9 here. So selecting those records, we have several marks. We cannot detect a single mark. And if we, for instance, have only subject ID, like this 42, but we do not have student ID, we also have several marks, and we cannot detect the exact mark. But only having both student ID and subject ID, we can detect the exact mark for this combination. So this is full functional dependency. With partial functional dependency, the situation may be as follows. We also have student ID, subject ID, mark, and the payment type. For instance, some students are paying themselves, and for some students there some money from state budget or something like that. So we have several payment types. But we may easily see that that payment type does not depend on subject ID. We can easily omit the subject ID here. We should only know the student ID, and we see here is 1, here is 1 for this student, this is 2 for this student, this is 1 again, and so on. But we do not have to have that field. So that's partial functional dependency. And just a quick overview and reminder. With functional dependency, we have a set of values, and for each value of that set of values, we have the same result. With full functional dependency, we have a set of values, and we absolutely have to have all those values in order to detect the result. But with partial functional dependency, we can easily omit something from that set of values, and we still be able to detect that final result. The third normal form and bisecond normal form are related with transitive or redundant transitive dependencies. The idea here is the next. With transitive dependency, we have a chain of dependencies, and we cannot skip anything in that chain, because once we skip something, there is no way to jump from the beginning up to the end. Absolutely no way. But with redundant transitive dependency, we also have that chain, and we may easily skip something because there is a way to jump from the beginning to the end at once. Here is the example with data. Let's start with transitive dependency. We have some results for some exams, we have student ID here, we have average mark, and some label. We cannot jump from student ID to the label because the label depends on the average mark. So we absolutely have to make the first step and then the next step. This is transitive dependency. With redundant transitive dependency, the situation may look as follows. We have student ID, we have some pass ID and student name. And we know that one student has one pass. And for each one pass, there is only one student name. So if we want to jump from student ID to student name, we can make it easily at once, because for one student ID there is only one student name, and we may omit this field from our sequence. So this is the redundant transitive dependency. And functional dependencies may be either trivial or non-trivial. The idea behind this is the next. With trivial functional dependency, we have two sets, and the X set is superset of Y set, or the Y set is the subset of X set. With non-trivial functional dependency, these are two different sets, so one is not a part of another. As you can see from definitions, trivial functional dependency always holds, while non-trivial functional dependency may be violated. Let's see an example. Imagine we have such data set, and we shall review trivial dependencies. We have a set of student ID and subject ID, and we want somehow to detect student ID based on this information. But of course we see that student ID is already here. So once we know this combination, we absolutely know student ID. And the next, by this combination we have to find out subject ID. But the subject ID is already here. So once we know this combination, we absolutely for sure know the subject ID. But with non-trivial functional dependency, based on this set, we have to detect the mark. So there may be variations. Imagine such a student ID as 999. We can see no value here. So what is the mark? And so on and so forth. So once again, trivial functional dependency always holds, while non-trivial dependency may be in some cases violated. And in the next video we shall discuss more complex cases of dependency theory.